ask that you do the same thing on your notes and change these. Okay? Okay, are we ready? So it says if f prime, so that's a derivative, and the derivative is continuous on some closed interval from a to b, and little f is the antiderivative of f prime on a to b, then I'm going to write it this way. What do you think happens if I integrate a derivative? What should I end back up with if I integrate something that's already a derivative?
The original.
The original. So basically whatever f of x is, I'm going to put this little bar here, because that bar means I'm going to evaluate this original from the lower limit a to the upper limit b. And the way I do that is actually plug in that upper limit and evaluate the function at b, substitute in b, minus what I get when I substitute in a, and that's what that is. That is the fundamental theorem of calculus. Okay? Now, graphically, that integral can be a lot of different things. It could be, in a word problem, it could represent the accumulation of oil in a tank. It could represent the accumulation of a population. Graphically, this is really what I'm talking about here. Okay? Now, you've already done this where you know that that integral represented the area accumulated from A to B, right? Okay? Well, if I don't see this picture, is it safe to say that if I go from 0 to B, that would be this area, right? Right? And then if I go from 0 to A, that would be that area, right? So if I take the value going all the way, the function value there, and then what I get from there, would it give me what's left here?
Yeah.
Okay. That's what's happening. That's what's happening. The thing is that you're doing it a little differently is now you're actually going to do the computations without a picture, because up until now that's what you've been using pictures and coming up with the areas, right? Is that what you all did? Some? And then you also practiced antiderivatives with u substitution and all of that, right? Well, now you get to put all that together, but without the pictures. Okay? So, let's go ahead and see if we can do that. All right. So notice what it says. Basically, find your antiderivative, and then you're going to plug in those limits. So that's what we're going to do here. What is the antiderivative of 4x to the third? What's the rule? What am I supposed to do?
Bump up and divide.
Bump up and divide. You know this. You know this. So, a weekend just erased the knowledge over the weekend?
Look
All
out,
right.
the long weekend coming.
I know, I'm scared to have what's going to happen with this coming weekend. 4x to the, what is my new exponent?
4.
Divided by the new exponent
4.
minus
6 squared
6x
divided by 2.
by 2. And then I'm going to put that bar, because now the bar lets me know that I have to evaluate it using the fundamental theorem from 1 to 2. I'm going to put an extra step in here where I clean this up a little bit. Go ahead and clean that up. What do I get when I simplify that expression? I don't need to write 4 over 4 because that's just 1. So I end up with minus, evaluate it from 1 to 2. Okay. And here's the big thing. That means I'm going to evaluate this expression from 1 to 2. Now here's the nearing the big finish. Because fundamental theorem means I got to take that big one and subtract from it what I get when I plug in that lower limit, right? So starting off with the upper limit, plug the upper limit into that expression. So we get 2 to the 4th minus 3 times 2 squared. I'm back in class now. Bye-bye. And then you must subtract. Remember, we had to subtract that, right? Plugging in the lower limit. 1 to the 4th minus 3 times 1 squared. And from there, it's just arithmetic. You should get a numerical answer once you're done.
Oh, so we don't leave it like that?
If it were free response, I would say sure, but we're going to practice finishing it on up. Yes, so let's practice our arithmetic. 2 to the 4th power is 16. 2 squared is 4, minus 3 is 12, so that's 12. Minus, that's going to just be 1 minus 3, right? So that gives me a negative. Is that correct? So what do we get here? 6. That's using the first fundamental theorem of calculus, and it depends upon what math book you use. Some math books call that the first fundamental theorem, some call it the second fundamental theorem. It's very easy.
Well,
It just added one little extra step.